everyone, I am Ayush Prasad from the Funtastic Academy. Welcome to a brand new episode about chemistry. Today we are going to learn about this brand new topic called chemical reactions. But first of all, we need to look at last episode's quiz question. What was the quiz question? Wait a second. Now remember. Which element has the highest electronegativity value out of the ones which we know the values for? If you guessed fluorine, kudos to you because you got it right. Now it's time to learn about chemical reactions. But first of all, we need to talk about a new law, the law of conservation of mass. So what is the law of conservation of mass? Well, it's a very simple law. Imagine a closed system. Nothing comes in, nothing comes out. So in this closed system, mass stays the same. Some objects can trade their mass with other objects, but the total amount of mass in the whole system will stay the same. You might be thinking, where did this law come from? Well, the ancient Greeks proposed it a really long time back, but it was Lavoisier, who I taught about in a previous video, who made it a law of physics in 1789. This law was later disproved in 1905 by Mr. Superstar Albert Einstein, but still, that's a pretty good one. So, how does this conservation of mass help us in chemical reactions? Let's look at a quick example. Well, you know photosynthesis, right? Well, that's a chemical reaction. But what does that even mean in the first place? Simply put, a chemical reaction is when you have molecules called the reactants, and the atoms in the reactants, they get all mixed up. So, they form new molecules called the products. Reactants are what you put in, products are what you get out, and the chemical reaction is the machine that turns one into the other. For example, take photosynthesis. What do we need to get our photosynthesis on? Well, we need carbon, which is represented with a C, oxygen. Actually, we need two oxygens, so we write the two. So, carbon, oxygen, oxygen. CO2, carbon dioxide, which is one of the things we need to get photosynthesis on. Another thing is the water. This is where you water your plants. H2O. Two hydrogens and one oxygen. And we also need energy. Now, why do we need energy? Well, our machine, it can't run by itself. It needs some energy, which is called activation energy to start running. So this is where our energy comes from. Now, what do we get as an output? We get oxygen for us to breathe, and we get this crazy thing called glucose, also known as sugar, which is 6 carbons, 12 hydrogens, and 6 oxygens. Now, seems simple, right? No, this is not the equation. There's 1 carbon on this side, but 6 carbons on this side. Violation of law of conservation of mass. So, what we do is that we put numbers next to the molecules so that they add up nicely. The real equation is 6 carbon dioxide, 6 water, 6 oxygen. Now, is this working? Well, let's see. How many carbons? 6 18, 12, 6, 18. It works. So this is the actual photosynthesis equation. Now, another example is breathing, also called respiration. Now, respiration is the exact opposite. You take in oxygen and glucose from your food and turn it into water and carbon dioxide, breathing out. Now, there are two main types of reactions. What are these two types? Let's find out. So, the two types are exothermic and endothermic. So, what do these two words even mean? Thermic means heat, right? So, we just need to analyze exo and endo. Exo means from outside and endo means from within. So, exothermic means outside heat and endothermic means inside heat. Now, let's think about these two words in slightly more detail. So, in exothermic reactions, they give heat away. So, it's giving heat to the outside. Endothermic reactions, they suck in heat. So, heat is kept inside. Now, let's look at the energy curve. For an exothermic reaction, the energy is the same until you add that extra nice little activation energy to get things started, and then it goes down. Now, this final energy is lower than the initial energy. But in an endothermic reaction, after all is said and done, the final energy is higher than the initial energy. So, is photosynthesis exothermic or endothermic? Well, it's taking heat from the outside. So, endothermic is photosynthesis. But both exothermic reactions, well, it's respiration. You are giving out energy. The energy from outside is getting given out into your body. So respiration is in this category. And so that's pretty much all we need to do. Except that there's some fun facts we still have not discussed. So let's see those fun facts. Have you ever heard of a catalyst? See, some reactions, like the reaction that powers your car, happen pretty fast. But some reactions, like the one that happens when a near us, happen pretty slow. So for the slow reaction, scientists use a thing called catalyst. Now, a catalyst simply speeds up a chemical reaction. And while we are speeding up, temperature is simply a measure of how wild the atoms are in the substance. For example, low temperature substances behave like this. And high temperature substances. So, if you speed up the chemical reaction, more atoms will collide together. And if they collide in the right orientation, direction, collide like this and not like this, and with enough energy, they make a chemical reaction. Now, there's this point called the equilibrium point. Basically, if you start a chemical reaction at the equilibrium point, the number of reacted molecules and the amount of unreacted molecules, that is the ratio between the reactants and the products, will stay constant. As many reactions happen this way as happen that way. Now, the equilibrium point isn't always 50-50. We need to do experiments to figure out what the equilibrium point is. Now, those are a few fun facts about chemical reactions. I'll see you later. Wait a second, the quiz question again. Okay, so the quiz question for today is very simple. Is photosynthesis an exothermic or endothermic reaction? Give your reasons why and listen to them in the next episode of your Funtastic.